So again, we are still looking at our water potential practice worksheet. So question 2, it says the value for water potential in a piece of root tissue is determined to be negative 3.3 bars. The tissue is placed in a 0.1 molar solution of sucrose at 20 degrees Celsius in an open beaker. What is the water potential of the solution, and which direction will the net flow of water be? So you're supposed to stop and think about how we might solve this before looking at the steps below. So I am seeing that we have 20 degrees Celsius and we have a temperature and a concentration. So we might be asked to calculate our solute potential. We know that it's in an open beaker, so our pressure potential is going to be 0. So we'll probably have to figure out the solute potential, and then that will become our water potential and compare those two, right? So our first, it says calculate the solute potential. So I'm going to start by writing down all the information we have. We know, because this is a solution of sucrose, we know that I is going to be 1.0 because it doesn't ionize. It tells us that our concentration is 0.1 moles. And our temperature is going to be 20 degrees Celsius, but we need that in Kelvin. So it's going to be 298 Kelvin, right? And R is always going to be 0.0831. So to calculate the solute potential, we use the equation solute psi S equals negative iCRT. So you just plug all these values in, 0.1, 0.0831, and 298. 298, 293, I'm sorry. 293 Kelvin. So then when you multiply that all together, you get negative 2.43 as your solute potential. So next, we want to calculate our overall water potential, right? So water potential equals pressure potential plus solute potential. So we know our pressure potential is 0 because we're in an open beaker, and we calculated our solute potential to be negative 2.43. So that means our water potential equals negative 2.43. And finally, decide which way. So we need to compare the water potential of our cell to the water potential of the solution. So we just calculated the water potential of the solution. So that is going to be negative 2.43. And the reading in here tells us that a piece of root tissue is determined. So this, what would be our cell, is going to be negative 3.3 bars. So we want to think about which one is bigger. So which one is closer to 0. So negative 2.43 is going to be closer to 0, so it's greater. So that means we add our arrow up there. So the water is going to move into the cell. So water moves into cells. The water always moves from low to high water potential. So we have that arrow there telling us that. So that is number 2. If you have any questions about that, let me know and I would be happy to help.